Good morning. My name is Wang. I'm a research assistant from West University. And today I will present our initial attempt in using a mathematical latent factor model in analyzing instructors' content preferences. The first question I need to answer is, why do we analyze the content preferences for instructors instead of for most prior work has done on students? What use is analyzing the preferences for instructors? And we argue that instructors are an irreplaceable role in education systems. They consistently use their expertise and domain knowledge to improve and to help students achieve their objectives. In this process, they produce potentially mass amount of data that we can, when, for example, interacting with learning resources, such as assigning homework questions to students. And we would like to harness the data in order to incorporate the instructor's domain knowledge and expertise in today's existing personalized learning systems to help improve their effectiveness. And this is the overarching goal that this work is aiming after. To narrow down scope a little bit, there we go. To narrow down scope a little bit, we're going to focus on a very specific kind of learning educational content, which is the questions that the instructors choose to exclude from the students' homework questions. Now, this sounds a little bit weird. Why do we focus on this content? Because we have a very interesting motivation from OpenStack Tutor. The OpenStack Tutor is a personalized learning platform developed at Rice University. It has a functionality to automatically select some of the questions for the students. And the instructors, on the other hand, has an option to opt out some of the questions from the question focus. So this automatic question selection tool will never choose those questions for the students. And the problem here is that there are simply too many questions that the instructor can choose from. Take biology, for example. There are almost 900 questions in the biology course, and the instructor has to manually sift all of these questions in order to pick the ones that he or she doesn't like. So we want to automate this process as the short-term motivation. And we do this by essentially predicting and understanding the preferences for the instructors in excluding questions. The contribution for this work is as follows. So we developed a latent factor model for predicting the instructors' question exclusion preferences. And also we use the Bloom's taxonomy tags for each question as an additional source of information to help explain why instructors exclude certain questions. The implication is twofold. In the short term, we want to develop this tool at OpenStack Tutor so that we can help instructors to automatically exclude some of the questions to save them some labor. And in the long term, we really want to learn about the content preferences of those really good instructors and incorporate their expertise and knowledge into the existing personalized learning systems to improve their effectiveness. I've talked about using Bloom taxonomy tags of each question as additional source of information. So let me give a short intro of what Bloom taxonomy is. Bloom taxonomy is a hierarchical way for classifying questions in one of those 6 levels in terms of increasing cognitive complexity from bottom to up, from remembering as the lowest level all the way up to creating. It describes the cognitive process that the students engage with or work with knowledge, and in our case, is answering questions. And each question uniquely belongs to one of those 3 levels. So our hypothesis is that we can, instead of predicting the instructor's question exclusion preferences for each of the questions, we can use the instructor's preferences for the Bloom taxonomies as an approximation for their exclusion preferences for each of the questions. And the idea is that we now use a far smaller set of factors. There are only 6 Bloom taxonomy levels to help explain the preferences for each individual questions. So before going into explaining the model, let me talk a bit about the data that we work with doing experiments and evaluation. We take the biology textbook from OpenStack's platform. There are 20 instructors teaching the course, and there are 896 questions in this textbook. Together, it constructs a binary preference data matrix in which an entry 1 in this matrix means that this instructor has explicitly expressed exclusion preference of that particular question, and the entry 0 means that the instructor doesn't have a particular preference, either exclusion or inclusion of that particular question. So now we understand the data. Here is our latent factor model. What's happening here is that we model the data matrix Y using a Bernoulli distribution with a bunch of latent factors, shown here as P, A, and G and H. And the latent factors, in particular, P and A, have specific interpretations because we use Bloom taxonomy tags in our model. And basically, what's happening here is that the factor A's are the question Bloom level association factors. And we obtain those factors from the question metadata in our data set. We use a simple one-hot encoding for encoding this external knowledge. So basically for example, the question J over here has a non-zero value on the second index, which means that this particular question J is associated with the second level, Bloom level, which is understanding. And now this factor P here is the instructor Bloom level association factor. And this is the factor that we want to use to give an interpretation of why instructors have different preferences of excluding different questions. The expectation is that the larger the value at the index of this factor, the stronger the instructor prefers to exclude questions belonging to this particular Bloom level. Okay, with this in mind, we did two sets of evaluations. The first one is about prediction, and the other one is about model interpretability. So in the first one, we want to show that our model is able to fairly accurately predict what questions each instructor is likely to exclude from the question corpus. And we will compare our model, and here's the results. So we compare our model with several baseline methods, and those are the methods popularly used in today's commercial recommendation systems. Basically, they are user-based and item-based collaborative filtering methods, and also singular value decomposition methods. We used a very simple evaluation metric here. Is basically the accuracy. That's the portion of how many correct predictions compared to all the predictions out there. And what we can see here is that our model, shown on the first column, performs comparatively or even slightly better than than the baseline methods that we are comparing with. Which means that by incorporating the Bloom taxonomy tags as an additional data source, we are at least not losing any of the predictability of our model. So with that, I want to, and we did a second set of evaluation, which is we want to show that, we want to understand why these instructors exclude certain questions, and we want to do this by using the explanation of Bloom taxonomy. Specifically, what we want to show is that the values in the Bloom level instructor Bloom level association, those values can give us some information about whether each instructor is likely to exclude certain questions. And I want to illustrate this by using two particular examples of questions from the question corpus belonging to two different Bloom levels. So here, what you see is a question of Bloom level 1. Remember, this is a simple recall question, as you can see here. And let's take a look at three different instructors and examine the corresponding value in their instructor Bloom association factors. So what you can see here is that from instructor 3 to instructor 9, the corresponding value in their factors increases. And if you remember our expectation from several minutes ago, we would expect that the higher the value is, the more likely the instructor is to exclude questions belonging to this particular bloom level. So we would like to say is that for example, instructor 3 has a weak exclusion preference of this question, instructor 5 has a moderate exclusion preference, and instructor 9 has a strong exclusion preference of question belonging to this bloom level. And what we want to do is to compare whether those values actually correspond to the real exclusion data that those instructors show. And and here's the comparison. So instructor 3 and 5 actually excluded this question, whereas actually didn't exclude this question, and instructor 9 did exclude this question. So from this example, we can see that those values sort of meet our expectation, which means that the larger value is, the more likely or the stronger the instructor prefer to exclude question of this particular bloom level. And just as another example, we can examine another question belonging to bloom level 5. The question is, which of the following statements about chemiosmosis is false? This is a more involved question than the one that you see before. So let's examine these three instructors and the corresponding value in their factors once more. These values change a little bit. Basically, you see that instructor 3 still gets the lowest value. Instructor 9 now has a moderate value. Instructor 5 has a fairly large value. So from this, what we want to say is that instructor 3 has a weak exclusion preference of this question. Instructor 9 has a moderate exclusion preference, and instructor 5 has a strong exclusion preference. Let's once again compare those values, how strongly we can say about the exclusion preference of this particular question from the values we observe here to the actual exclusion preference that we observe in the data set. In this case, instructor 3 didn't exclude this question, whereas instructor 5 and 9 did exclude this particular question. So we would like to say that the values we obtain in those instructor-bloom association factors are informative of whether the instructors prefer to exclude certain questions. So in summary, in this work, we developed a latent factor model to do primarily two things. One is to predict what questions each instructor is likely to exclude. And the second is that we use the Bloom taxonomy as an external data source to provide an explanation of why instructors prefer to exclude certain questions. And as I said in the beginning of this talk, this is a very initial attempt in using this model for modeling the instructor's content preferences. And obviously, there's a lot more to do here. For example, we want to exclude some additional information besides Bloom taxonomy to provide a richer explanation of why instructors exclude certain questions. For example, does instructors prefer to talk about certain sections of the textbook, or certain chapters, certain sections of the textbook, so we can include the chapter selection as an additional data source. Just as an example, for another additional data source that we can use to incorporate in the model. And secondly, for the longer term of this project, we really would like to analyze the content preferences of instructors, not just about the questions they exclude, but maybe the questions they include, and also for other content preferences that the instructors may exhibit when they are interacting with learning resources. And if we are able to expand the model to other contents, that would be more useful, not just for the OpenStax case in this very specific setting, but to a broader education scenarios. So there's a lot more to do here. And with that, I would like to acknowledge my advisor, Rich, and my mentors, Andrew and Philip, about this project. And that concludes my talk, and I'd like to thank you for listening, and I'll take questions from the audience. Thank you.